In this video, we're going to talk about how to create a residual plot. Now, a residual plot, as I state here in the box, is actually just a scatter plot. But instead of using an X and a Y, it's going to use X's and residuals to make a picture. Now, there's a reason why we create this test. Or, not this test, but this picture. We're trying to test something with it. The idea is again, that our residuals are errors. And so I'd like you to think really quickly about errors in general. Let's suppose on an upcoming test in this class, you make some errors. Now we could maybe try to keep track of what errors you make. Maybe on a certain problem, you write an incorrect hypothesis. Maybe on another problem, you round something to an incorrect number of decimal places. Maybe on another problem, you just make a calculator error. But we could start to kind of record all the different problems that you make. And something interesting can happen if we understand the types of mistakes that a person makes. If you knew that on, say, every problem on the upcoming test, you were to consistently write hypotheses incorrectly, right? You just, every time you got your hypotheses wrong. Maybe even more specifically, let's say you always got your H1 wrong. Every time your H0 was good, but H1 was always wrong. If there is a pattern to the types of errors that you make, then it's possible that you could go and fix it. So if you always got your H1s incorrect, then you would kind of know what to study. And probably by the time the final exam gets here, you would hopefully have been able to fix that particular issue and improve. But if you were to look at your exam and you were to see that you made all sorts of different errors, and they were kind of all scattered about, and it was hard to really find any sort of consistency into some common incorrect way that you were thinking about things. If these errors were kind of just random, then it would be much harder for you to try to improve. This is the idea of our residual plot. Our goal right now is to try to make sure that if we're going to test to see if there are linear relationships between data, then we want to make sure that a linear relationship is kind of the best shaped relationship to work with. And we'd like to see if we could do any better than a line. In order to do that, we'll go ahead and create this picture, and it's going to hopefully show us that there is no predictable pattern to the residuals or to the errors that we're making, because that would mean that we would have no easy way to try to improve. So as I state here, we're really going to hope that this residual plot, which is a scatter plot, is going to look like a random splattering of points. So let's see how we would do this. I'm going to go ahead and get my box ready for how to draw this picture. And let's go ahead and go to the calculator and create this. So coming back here, this was my normal probability plot. I'm going to go back to my y equals, and I'm going to change to this first option for a residual plot. It's a scatter plot. Now, I want to make sure that my first list contains my x's, which I have in L1, and my next list contains residuals. Remember, you can get residuals in here by clicking on second and stat, which gives you the list of all the different lists on the calculator. Once I have this, I can click zoom and 9 to see the picture. And I get a picture here of something roughly approximating the shape of the United States, I'm going to say. Okay, so if I was to go ahead and try to sketch this picture back on the page, I'll notice that there is a horizontal line that kind of comes across. Okay, and then I have a bunch of different dots in some different locations. Let's see, I got like a dot here and there and there, and then I got some going like this, and one down here, and over there, and here, and there, and maybe up there. Okay, so this is roughly my picture. And what I'm looking for here is that these kind of distances away from this horizontal line represent my residuals. They're the errors. And so I can see that this is an indication of a residual, a residual, a residual, a residual. And I'm curious, is there any pattern to the residuals that I have listed here? Well, if I take a look, I kind of would say this is closer to being just like a big random splattering of points. There's no pattern. It's hard to tell if the data points are, like if I was to say I'm going to draw another data point and it's going to be right above this spot on the x-axis, or it's going to be right above or below this line. Should it be above or below? What would fit the pattern? It's really hard to say. So I can say here that there is no predictable pattern And that's actually good news because this means that a line is a good way to model the data. It's probably the best way. Notice we're not saying that a line is best to model this data, but the line is maybe best to model the actual car data itself. Now, you could see this pretty easily if we were to go take a look at the actual scatter plot, which would have list number 1 and list number 2. This is the actual car data, and we can see my line of best fit coming in here. And what we've really showed with the residual plot is we can't come up with a better way to kind of model this data. A line seems like a good shape. It doesn't seem like something curvy or bendy or increasing and then decreasing is really going to be any more helpful. A line is a pretty good choice. And this is very important for us to be able to do if we're going to say that we're going to create lines to model our data.